Hello future engineers, welcome to my YouTube channel. And if you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can keep me going and refreshed. So here is a problem with yielding of supports, and I'll present double integration method here to demonstrate how powerful the method is. In fact, if you master double integration method, then this will be your tool. You can make this your main tool in analyzing continuous beams. And it is a powerful tool that you don't need to memorize or master other methods like three moment equations, slope deflection equations, and the moment distribution method. So take note of this problem because I will also solve this by other methods like uh, hmm, three moment equations, slope deflection equations, moment distribution method, um, and the method of least work. So watch out for this problem later. But in this problem, I will only present double integration method. So take note that joint A rotates 0.002 radians. So when x is 0, the slope of the tangent at A is negative 0.002. So we will call the reactions at A upward positive and moment plus positive as shown clockwise, RB and R sub C. Then let's section portion CD to set up the dif differential equation of the elastic curve. So EIY double prime is equal to RA times X plus RB times quantity X minus 6 plus R sub C quantity X minus 14 plus MA minus 60 times X minus 3 minus 30 times X minus 6 times X minus 6 over 2. So that's why you have 15 minus X minus 6 quantity square. So also that MA is not multiplied by X minus something because it is at the origin raised to 0. So you can write it that way if the couple is acting at the origin, not at any other point. So integrating once, EIY prime is equal to RAX square over 2 plus RB quantity X minus 6 square over 2 plus R sub C X minus 14 square over 2 plus MA X minus 30 times X minus 3 square minus 5 times X minus 6 cube plus C sub 1 after integrating. So there is C sub 1 because there is slope when X is 0. There is rotation of A. And EIY equals RAX cube over 6 plus RB quantity X minus 6 cube over 6 plus R sub C quantity X minus 14 cube over 6 plus MA X square over 2 minus 10 quantity X minus 3 cube minus 5 fourths quantity X minus 6 to the fourth plus C sub 1X. There is no C sub 2 because when X is 0, Y is 0 at A. Take note of the principle. Then we will evaluate C sub 1 when X is 0, Y prime is negative 0.002 because that's clockwise. Rotation clockwise or angle in clockwise direction is negative. So EI 40,000 times negative 0.002 equals C sub 1. When X is 0, everything here is either 0 or ignored because these terms are not applicable when X is 0 or negative inside the parentheses. So C sub 1 is equal to negative 80. Then we substitute it here for the boundary conditions When x is 6, y is negative 0.03. And when x is 14, y is negative 0.02 or 20 mm, 0.02 meter. So 40,000 times negative 0.03 when x is 6 is RA 6 cubed over 6. This is 0, ignored, plus MA 6 squared over 2 minus 10 times 6 minus 3, so 3 cubed. Then 0 plus C sub 1 x, so plus negative 80 times 6. Setting up the first equation, 36 RA plus 18 MA is equal to negative 450. Let's call that equation 1. Then, when x is 14, y is negative 0.02 meter. So 40,000 times negative 0.02 equals RA 14 cube over 6 plus RB 8 cube over 6 plus 0 plus MA 14 square over 2 minus 10 times 11 cube minus 5 fourths 8 to the fourth minus 80 times 14 plus C sub 1x. Simplifying, 1372 over 3 RA plus 256 over 3 RB plus 98 MA is equal to 18750. Call that equation 2. Then from equation 1, because EIY double prime is moment, so when x is 14, here at C, the moment at C is negative, so clockwise positive. So MC plus 30 times 2 times 1, so M sub C is negative 30. When x is 14, moment at C is negative 30, so let's substitute it here in this equation. Negative 60, 30 times 2 times 1, so negative 60 equals RA times 14 plus RB times 8 plus 0 plus MA minus 60 times 11 minus 15 times 8 squared. So take note that this equation is like summing up moments about C considering the beam equals 0. So it's like that. Or simply substitute it here because this is the differential equation of the elastic curve and EIY double prime is interpreted as moment at any other point. We know the moment at C to be negative 60 or negative 30 times 2 times 1, so negative 60, so that's why we substitute it there. So simplifying this equation, 14RA plus 8RB plus MA equals 1560. So solving these three equations simultaneously without further solving the details because that's mathematical. So you were trained to solve simultaneous linear equations. You may apply substitution, matrix, or whatsoever available tool you are convenient with. So the results would be RA equals 32.2 kilonewtons, R sub B equals 149.825 kilonewtons, and R sub MA equals negative 89.4 kilonewton meter. Then apply statics to solve for RC. Summation forces Y 32.2 plus 149.825 plus R sub C equals 60 plus 30 times 10. So R sub C is equal to 177.975 kilonewtons. So that's it, and let's solve this again by other methods so that we can verify that these answers are correct.